achiral objects are objects that are superimposable on their mirror images, and in a minute I'm going to show you that a coffee cup is an example of an achiral object. Chiral objects are objects that are not superimposable on their mirror images, and the word chiral comes from the Greek word for hand, and so I'm going to show you how your hands are not superimposable on each other, but your left and your right hand are mirror images of each other. Let's take a look at a coffee cup reflected in a mirror. And so you can see on the left here is the actual coffee cup, and in the mirror is the mirror image of the coffee cup. And I'm going to pull out the coffee cup to make some space, and I'm going to put what I saw in the mirror image, right next to it. So here I have another coffee cup, so that's its mirror image. And I'm going to take the coffee cup on the right, I'm going to rotate it. And so as I rotate it, you can see that it is superimposable with the object on the left, right? So the mirror image is superimposable, and that's the definition of an achiral object. So we say that a coffee cup is achiral. Now let's try the same thing with a molecule. So this is difluoromethane, so the green are the fluorine atoms, and in the mirror you can see the mirror image. So once again I'm going to pull the molecule away and put what I saw in the mirror image right next to it. And I'm going to rotate the mirror image. So the one on the right, I'm going to rotate it to see if it's superimposable with the one on the left. And so I take it, and as you can see as I rotate, right there, you can see that it is superimposable with the molecule on the left. And since the mirror image is superimposable, we say this is an achiral molecule. So these are actually two of the exact same molecules represented here. Now let's look at my hand. So my left hand, and in the mirror you can see my right hand, or what looks like my right hand. So I'm going to take my left and my right hand together. We've just shown that they are mirror images of each other. And then I'm going to try to rotate my right hand to see if it's superimposable with my left hand. And so you can see here I have my palms both up, but my thumbs are not pointing in the same direction, so they're not superimposable here. And so I'm going to try again. I'm going to try to rotate it, right? So now my thumbs are in the same position, but my palms are not in the same position. And so no matter what I do, I can never superimpose my right hand on my left hand. So the mirror image is not superimposable upon the original object. So no matter what you do, you cannot accomplish this. And since the mirror image is not superimposable, we say your hands are chiral. Now finally, let's take a look at a molecule. So the white is hydrogen, green is fluorine, red is bromine, and yellow is chlorine. And so I have the molecules on the left, and in the mirror is the mirror image. So I'm going to pull out that molecule and once again leave some space and put what I saw in the mirror right next to it. So there's the mirror image. So I have these two mirror images of each other. I take the one on the right and I try to rotate it to see if I can superimpose it with the one on the left. And so here I just rotated it a little bit there. And you can see that the bromine atoms are in the same position. However, the chlorine and the fluorine, the yellow and the green, are not in the same position. So I cannot superimpose it here. I try again. I rotate it some more, and you can see the yellows are in the same position, the chlorine and also the hydrogens. But the red and the green are not. And so no matter how I rotate the mirror image, the one on the right, I can never get it to look like the one on the left. And since the mirror image is not superimposable, we say that this is a chiral molecule. And this carbon here, this is a very important carbon with 4 different substituents attached to it, 4 different groups. We call this a chiral center or a chirality center.